So now let's look at an equilibrium problem with a weak acid. And this really works like the others. It's just we're going to have a Ke instead of a Kc or Keq. Anyway, let's start by writing our reaction. If it's an acid, a weak acid, we're just going to start as our reactant, where it's unionized. And then as products, we're going to remove a hydrogen atom there. Just the one in the front. It's always the one in the front. We won't be doing any that have more than one here, because then you would actually have an equilibrium for each one of those. So I'm not going to get into that. So there's our reaction. For our initial, we're going to assume that it's not ionized at all yet. We're going to kind of pretend like this is all still intact. And then for the ions, then it's 0, because we're pretending like it hasn't ionized yet. So for the change, X is going to represent the amount that ionizes. So at equilibrium, and this part, of course, is where I just added those two to get my equilibrium expressions. Another thing we can look at is that we have an expression for the Ka. In other words, we can write down how it would be calculated. Okay, and we could put this in terms of X now, because we have those concentrations in terms of X. I'm just going to put it over here. So it's X times X. I'll just fill them in like this. Okay, well now what? Well, it also gave us the pH. And notice that the pH, if you look at this column right here, is going to be related to X, because in this case, X is the hydrogen ion concentration. So since it gave me the pH, we know that pH equals negative log of the hydrogen ion concentration. I need to solve for this hydrogen ion concentration, and then I'll have X, and then I can plug in. So I'm going to rearrange this, and we showed this. So it's the inverse log of the negative pH. So that's the equation, and I get carrying extra digits for now. Okay, and then the big key was that this is X because of how it was defined up here. That's X. So then we can plug in to this and get our Ka. of course, this is unitless. Just ignore that. Unitless like all other equilibrium constants. All right, just a bit about sig figs. Of course, up here we had just 2 sig figs for our concentration, and this is 2 sig figs also, because remember the on a pH that front number doesn't count as a sig fig. I just carried extra digits when I used it.